evening, folks. Welcome to another OWASP Ottawa Chapter monthly meetup. Thanks for joining us here on the University of Ottawa campus, and for those who are joining us through the internet, if that is live or you're watching this at some point again in the future, thanks for stopping by. The OWASP Ottawa Chapter is a chapter of volunteers. If you're an organizer, raise your hand. There are other organizers without their hands raised, but that's just because they're shy today. It wouldn't happen without the support of volunteers. Thank you very much for everybody for all that you do. If you would like to get involved after you've been here and experienced what it is that we offer to the community, please don't hesitate to either find one of us, somebody who had their hand up, or find us on the internet. You can find us at owasp.org/Ottawa, where there's a list of all the other great places that we've got some kind of a profile. One of those is our Slack community, which I highly recommend you join because it's probably the best place to stay connected if you can spin up a Slack account. But again, we're not hard to find. And you will typically find us here on the third Wednesday of each month. And we're really grateful to the University of Ottawa, the IBM Cyber Range, for the space that they provide us. So how about a round of applause for them? Thank you also to Xanthus Security this month for some fantastic pizza. Xanthus is a penetration testing and red teaming company here in Ottawa, and they've certainly fed us well tonight. So thank you to the Xanthus team. Other announcements that are important. There's nothing immediately coming to the top of my mind. We've got a party coming up in October. I think we talked about this last month, the OWASP anniversary party. We are one of a limited number of chapters around the world who've been invited to throw a party in celebration of the anniversary of OWASP. So that will be coming up again, as I say, in October. Stay tuned for that. And again, you can learn about that on our Slack community. Find us at owasp.org/Ottawa, and you'll see our Slack community link there. With that, how many people have a computer laying around that they wish that they could do something with, but it's just not able to run 140 tabs of Chrome anymore? I got a couple of those. It is time out there when stuff's expensive. A lot of people are learning new skills because we gotta keep up with always learning new skills, and certainly in the time that we are presented right now. So I'm super excited to introduce Chris Shepard here today. Fennix, not the DJ, if you're old enough to remember that Chris Shepard and have those records. I confirmed, not the guy. But what he does have a lot of experience in, well, is talking about this stuff. And in particular, I'm excited we're gonna hear about how you might be able to reduce CVE waste, maybe leverage some stuff that's kicking around in order to build your own labs for learning and testing and not have to shell out a whole bunch of cash. So without further ado, I'm going to introduce Chris, who's promised to keep this to under 2.5 hours. Right? Yeah, great. Fennix, everyone.
One, two, testing. Can you guys hear me okay? All right. So, thank you for believing that I'm old enough to be that guy who was the pirate radio DJ. All right. So, obviously, show of hands in the room at any rate. How many people here are any kind of PC gamer? Okay. For the YouTube audience, is about half, maybe 2/3. So you probably, some of you have already heard everything that's going on. We'll get to that in a second. I'll start with who I am. A lot of you folks probably know who I am because I've presented a few times at OWASP. I've worked with many of you on various things. But my name is Chris Shepard. I'm a pen tester at Xanthus Security. I've been doing pen testing for about 10 years. I have a bit of a security interest and have throughout my life, dating back to my youth. Everybody's misspent youth is different. Mine was tinkering with phone systems and stuff I don't want to go into. I have, over the years, my career has been fairly varied. I've done roles from database administration to network admin to, I was an AD guy very briefly, to customer support. Throughout that whole time, I was kind of interested in being a hacker, but when I started out, hacking was a way to get to jail, not a career. So I've long been a privacy advocate. I think there are a lot of obvious reasons right now in the news. I probably don't need to tell you guys like why that's important. So I'll just say I've always kind of advocated for not collecting information that's not needed. The bolded point here about being an avid home labber, maybe to my family's chagrin, I have been doing home labbing for a long time. It's always been sort of a source of tinkering for me. I like seeing how different pieces of software work. Gives you an idea of like different ways to architect systems and things like that. If you're not familiar, home labbing is just running servers for yourself at home, having services that you're interested in running. Most people probably are familiar with like media services, so things like Jellyfin or Plex or things like that, where you can run your own media library at home and abroad, depending. But home labbing can be a lot more than that. And then lastly, I'm a challenge developer at CyberSci. That sort of dovetails into the home labbing thing because I have a lot of resources at home to be able to just build a fresh system and then build challenges. CyberSci is a post-secondary cybersecurity CTF. So it's targeted at university and college students. There's sort of like age gates on it. But it's kind of a cool event. We had something, I think 400 or so students participate in our last regional event. And basically what happens is the winner of each region comes to Ottawa in the summertime. So we're in the sort of preparation stage for that. But it's fun. It's great. Winning team gets to go on and sort of represent Canada at international competitions. So if you know somebody or are somebody who's in that sort of cohort, pass it along. Yeah. So I really like this quote for two key reasons. It's an update on a very old quote about the Voyager spacecraft and how you could accomplish incredible feats. Going to the moon is another thing that often people will raise. But you can accomplish incredible technological feats with good thought, good engineering, and you don't need crazy horsepower. You don't need crazy amounts of bandwidth or things like that to accomplish them. We're still getting data from like one of the Voyager probes. It's the furthest flung man-made object ever. I don't know how long ago that was, like 55 years or something like that. It was before I was alive, I think. But this sort of illustrates that technology has continued on, and now even just like your key fob for your car has a microprocessor in it that's more powerful than what's running the whole show for those probes. That has sort of been a blessing and a curse, right? You can't buy dumb anything anymore, it feels like. Every fridge has to be a smart fridge. Every toaster has to have Wi-Fi for some reason. Like, who needs that stuff, right? But on the flip side, what it means is that it's effectively like the commoditization of compute. So everybody has pretty powerful systems at hand. You just got to know how to use them, I guess, or realize that they're there. This is going to be the sort of outline of what we're going to discuss. We're going to talk about sort of the state of the world right now for PC parts specifically. If you're a gamer, you probably already know most of that or have experienced it. And then we're going to look at like the reasons why you might want to do a home lab for yourself, like build your own little home testing network or whatever. I think there's like a handful of compelling ones that go beyond just, I'd like to be able to run my own media server at home or something like that, which is one of the most common and popular ways to do it. I'll outline sort of what I think are the key pieces you need to build out a home lab. I'm going to be upfront. This is very opinionated. Other people might do things in a vastly different way. But I want to encourage people that and let people know that this stuff is out there and you can sort of do this. I encourage it. And then I'm going to go through one example setup. It's going to be based on one particular virtualization technology. There are several, okay? And I'll give you some options when we get there. I don't want this to be seen as an ad for that thing. I picked it because of the specific requirements I had, and I've just found it to be a very robust tool, okay? And then the last thing we're going to do is we're going to put it to use. So who here has heard of the Notepad++ compromise, for lack of a better word? So there's two parts to that, right? One was the actual threat actor compromising Notepad++. The other was the lack of code signing on the application side for updates. So what we're going to do is simulate being the threat actor and compromise Notepad++ and have it install whatever the hell we want on a victim Windows system. So that's what we're going to do with our lab, because I literally have a computer at home that's sort of set up exactly the same way this is, but an older PC, and it is currently doing this kind of work for me. So I think the picture says it all. This is sort of the sad state of tech. Why is this so ridiculous? Well, this is a chart of memory pricing for DDR5 memory going back 18 months. It's from PC Part Picker. If you've never seen PC Part Picker, it's a website where if you want to build like your own computer at home, you can sort of price it out in US dollars and then see what you can compare. Beware, if you're in Canada, there's a Canada tax to a lot of these things. The important lines to pay attention to here are the purple line at the bottom. That's at $100. Okay, so for most of last year, it was maybe 110, 115 bucks for 32 gig of DDR5, 6,000 memory. Now the interesting line, in quotes, is the green line at the top. That is $500. So since about September last year, prices have skyrocketed for DDR5. DDR5, if you're not familiar, is like the kind of the current gen for most new systems you would buy today. Let's take a look at what happened last year's or last gen's memory. Same thing, basically prices tripled, over tripled in most cases. The line here is $75, the purple line, and then the top line is $250. Same problem, memory just got more expensive. DDR4 has been around for a long time though. It's been around since like 2017, 2018. So it's been in use, actually maybe even earlier than that, but it's been in use for a long time. And even though it's an old technology, in theory, no one's speccing out data centers with this stuff. It's gone. Now, the reasons it's gone, AI companies, and this is going to have knock-on effects because you got to think about every component that needs or uses memory is now more expensive, right? I think most gamers traditionally are used to the GPU being the most expensive part of the system. It's been that way for a long time. Your graphics card does all the hard work for gaming. It makes sense to spend like $1,000 on that. Makes sense, right? The problem is, if you consider the total cost of a system build, right? Your graphics card is $1,000. These other parts might still be the same price. Let's say your CPU is a couple $100, your motherboard's a couple $100, your SSD is a couple $100, and then the memory jumps. You're paying basically like 20 to 30% more for your system than you were last year. And the reason is one AI company in particular, but then several other companies tech companies jumped on the same train, essentially inked deals, almost like exclusivity deals for huge amounts of memory because they see this huge growth in AI demand. AI needs memory. So you want to go to the supplier and say, hey, listen, we aren't getting GPUs fast enough. We need more compute. We need more GPUs, which means they need more memory to fit these bigger and bigger models. So how do we get that? How do we secure that? And so they went and inked deals with two of the largest memory manufacturers to secure about 40% of overall worldwide memory supply for whatever over the next year or something like that. I don't know exact terms of it. The problem is that then creates, suddenly there's a supply drought. And as we all know, capitalism is great at being like, oh, I can gouge you. That has a knock-on effect to everything else. So NVIDIA, notably large AI related company, they're selling the shovels. They are delaying some of their new releases, which they haven't done in like 3 decades, because they don't need to. They're not selling to consumers or gamers anymore. They're selling to these AI companies, and they're going to focus on that. There are 2 memory manufacturers that have basically outright said, we're getting out of the consumer business. We're just going to focus on this, because they see it as the sort of path forward. SSDs use memory. They are also going to rise. You might see a return to people putting platter drives in new builds of systems, even though they're much slower, just out of necessity, because you can't afford $1,000 for an NVMe drive anymore. And then, that's going to then further inflate PC pricing. So if you want to build your own test lab, you don't want to buy a new system for it. I have long been an advocate of like, don't throw away old computers. My wife can attest to that. But the reason is that there's usually a way to put it to use, like give it away to somebody, is an often thing. The problem is that certain large tech company that runs a very popular worldwide operating systems development decided arbitrarily to draw a line and say, we won't work on this new version unless you have this hardware level. And so a lot of people were left with the impression that like, oh, these older computers are now useless. Obviously, most tech folks know that's not the case, but if you're not a tech folk and you're listening, yeah, that's not true. There's lots of ways around it even, which is kind of funny. So the idea is you can still use your old hardware. It's still safe to use. It's not inherently unsafe. You just can't put Windows 11 on it. I would encourage you to, wherever possible, free is king. So if you can get a system for free, if you have a friend who's like, yeah, I'm going to upgrade my laptop, I'm just going to throw my old one in the landfill. They're not like, laptops aren't like cars. You can't trade them in, right? So if they're going to just toss it, take their laptop. A laptop makes a fantastic sort of home lab setup, especially for doing mobile testing. I have this thing here is the laptop that I did everything on. Now, if I turn it on right now, it's not going to look very impressive because it's just a DOS prompt, basically. You're just going to see a Linux like login shell. But this is an older laptop it's basically my old daily driver, which is why it has all the stickers on the back, but from 2020. So it's like a 2019 model year laptop that I bought in 2020. I did all of the presentation stuff that you're going to see in a bit. All of the lab setup and everything was done on this one. Because my T470, which is older, from 2016 or so, is being used for this exact purpose for a different thing that I'm working on. So if you can find mini PCs too, computers that have to sort of be at a place, right? Like bank tellers, stuff like that. They have to refresh those systems, especially they were made to refresh them by Microsoft. So they're a good source of like, you can find bulk purchases of them online. And so it's a good sort of cheap source of those things. So then the question is like, okay, well, yeah, I get that you could do it cheaply, whatever, but why? This is, I'm going to just say, probably the most accessible that this kind of idea has ever been. There is better software for doing this kind of work than there ever has been. When I started out doing stuff, your basic option was you could run a virtual box somewhere, but you needed a GUI to get everything to work. Because back then it didn't have like a command line or an API. And then, or you had to set up VMware ESXi. Those were your options. Both of them commercial, pretty much. And so you didn't have options. And then Linux kernel virtualization matured, and there became more options. So we're going to go through an example using Proxmox, but there's like Incus, there's Cockpit, there's you can use straight up like raw native virtualization if you want to get into doing that. You can containerize and do things through things like Kubernetes and whatnot. It's just easier to do. There's more nicer interfaces for things, and stuff that didn't used to exist kind of exists now. And I'll show an example of that in a bit. The other reason might be cloud pricing. Anybody got a cloud bill in the last like a couple of years? It's slowly creeping up because their costs are also rising, and you can imagine what's going to happen if all the memory is gone to cloud data centers, and you can't buy your own new computer. They're going to just crank the prices even more. So I tried to find some, because pricing is never like a fixed thing with cloud. Like I think if they think you're interested, they're going to show you a cheaper amount. So I went to some aggregator sites to compare, and they roughly agreed that an AWS T2 Micro, which is 1 core of CPU and 1 gig of memory, is about $850 US a month to run it for the whole month. Whereas like so you can think of like using that old laptop you might have in a closet somewhere, if it's a quad core, is basically paying you $34 a month. That's how I would do this if I was going to give you a sleazy sales pitch. But I mean, it is kind of true that if you were going to do this on the cloud, you're paying that money out of your own pocket. Now, there are obviously other considerations, backups, paying for the electricity, the bandwidth, all that. If you're doing this for your home network, you don't care about bandwidth because you own the cables, right? Electricity is the main concern. We're kind of lucky here in Ontario. We have very reasonable rates compared to a lot of other places. And you can also, this is also sort of like you can sort of tag this as like a possible off-grid thing, right? Like if you wanted to have sort of cloud features, cloud storage features, but you live in a cabin in the middle of nowhere, you can do that if you have an old system laying around and some hard drives, right? This point in the middle of having a lab that you can do testing and everything with is an awesome career booster. I can't underscore that enough. Like, regardless of what is happening with, LLMs taking away people's jobs because tech companies are doing a weird shell game, the idea of a big barrier, if you just have your system, your laptop, you don't necessarily want to go through the steps of like, okay, I'm going to set up a virtual machine setup on my laptop. You might even be restricted from it if it's a work computer. But if it's something you want to learn, some new technology, you kind of have a way of doing that. If you've got another system that you can just say, I'm going to spin up this VM. I don't care what happens. I can fuck it up. Sorry for the language. but I can completely ruin this entire VM, and it does not matter. It's not going to affect anything. So it's great. It's great having sort of that disposable resource on top of it, but it's also very valuable for learning. I've learned a lot about pen test work and stuff just by having a setup where I can then test some things out. For pen test work specifically, I have, as I mentioned, an older laptop that is currently doing the similar thing at home. The older laptop is essentially acting like it's like essentially like treat it like a hostile Wi-Fi type attack, right? So you always hear don't go on the public Wi-Fi. Well, this is like an example of why. You'd be surprised at how many mobile applications just freely talk over HTTP for a lot of things, and it's astounding. But yeah, mobile testing, it's like a huge help. It can also be useful to be able to have like a test environment if you're trying to say in a red teaming context, if you're trying to compromise a security control, having a copy of that security control that's offline that you can just go at for as long as you want without being in the real environment and then setting off all the alarms, right? That's very handy. The last point is kind of more the traditional home labber route. If you want to de-Google or get offline or like bring your own services at home, there are loads of packages out there for you. Like, start by looking at, say, Nextcloud, Plex/Jellyfin and Home Assistant. Those are the three sort of biggest, most popular things, and they all kind of do their own niche. But you can get rid of Google Drive or OneDrive or any of that stuff and just have it locally, with the asterisk that you need to make sure you have an offsite backup somewhere, right? But a lot of that stuff is made easier. They have very good web interfaces. So, sorry, let's say you're convinced. My wife got to the slides. So how inexpensive can this actually be? It depends. So like, let's say you can't do free. Always, this message should be like 1A right here. Free is best. So if you have an old system, use the old system. If you have a friend ditching their system and they don't want to use it, take that. If you have somebody at work, befriend the IT guy at your office. Yes. Oh, there you go. That's perfect. Yeah. So getting like massive amounts of used hardware is great that way, especially if they're like, we're going to pay someone to come take this away, is the business relationship a lot of the time. So if you say, well, I'll take it for free, then you can have like whatever you want at home. You found a graphics card just in the recycling? And it worked. It was in the snow? That was definitely a breakup. Someone was chucking somebody else's stuff out on the lawn. That's amazing. Yeah, so I have an example here. I'm not trying to like promote any one kind of way of going about it. There are loads of liquidators and auction sites and stuff that you can check. I will caution you, things that are marked parts only will often be pillaged for all the like valuables. And these days it's all memory. So this talk, the initial genesis for it, for this presentation, I was like, kind of like sort of early fall last year. So when I was going through, eBay and Kijiji listings and stuff like that, I was seeing lots of stuff that was just like, system doesn't have a hard drive. That was the only thing removed from it. I'm seeing a lot more, no memory, no hard drive on the parts only flagged systems. So memory is expensive, right? So why would they give that to you for cheap? But these Think Center systems are exactly like the bank teller or, the hospital workstation kind of setup where it has to be in a fixed location. You don't want a laptop for that. The other thing I would say is like, if you're trying to do it on a shoestring budget, look for screen damaged laptops that work. Because I looked earlier today, and there was a couple of auctions that were like 98 cents plus shipping. Shipping is like $15. You got to watch for shipping because they'll be like, oh, it's $1, but it's $80 in shipping. That's not $1. You're getting a kickback somehow. But the damaged screen thing, a laptop, you don't care about that for a server. You don't need a screen on your server. For the setup, most of them have an HDMI port. You plug it into that, away you go, right? You don't care about it. And I didn't bring it. I forgot to bring it. But I have a Google Pixel 7 that I got for $80. If you look at the price of that, it's about $230, $240 for a used Pixel 7. I got it for $80 because it had a incredibly damaged screen. I wish I had brought it because I would show everybody. It has some slight ghosting that you can see on the white background, but most of the time isn't a problem. So I bought it as a testing phone because like I wanted an up-to-date phone because my previous one was like a Nexus 4 from, I don't know, 1970. But those are great avenues if you can find them. The tricky part is making sure that it works well enough, right? Like screen damaged could mean, well, someone appears to have dropped it down a cliff face and the screen was damaged, but actually the whole thing is bent in half. So just have a discerning eye. There are also like local liquidator places that will get stuff back from businesses and they do the liquidation. There's one, I can't remember what it's called. I think it's like Ottawa PC Liquidators or something like that. But the idea is you can just go in and ask those guys like, hey, if you have anything a laptop that will never be refurbished because the shell is cracked, like literally the only thing good on it is the motherboard inside the memory. and then I need to find a hard drive, they might be willing to give you some of that stuff either on the cheap or free, depending. If you're in the situation where you don't have an IT guy at work to go talk to, which is some people. So that's how to do it on the cheap. Now, this is me sort of demonstrating I'm not talking out my ass. This screenshot you see at the top is from one of my old desktop computers. So this processor's from 2012. I bought it around like just before Christmas time that year. And it has been running ever since in one of my basically as one of my servers. It was originally in a desktop box. It got moved around. It's had other things put in around it, but it's not a ship of Theseus. It is the same individual parts from 2012. So it's nearly old enough to drive, and it's working at home just fine. It runs some storage stuff. It runs my music streamer. And so it has jobs. At the time, I thought it was great to turn it into it because it's 8 cores. That's pretty amazing back in 2012. This line of CPUs is notoriously awful, though. So do not recommend. But it's good for server loads because servers don't have to care about cutting edge performance. They don't have to be super fast, right? In fact, you'll see most server processors are clocked much lower than desktop processors are. So they might have a max boost of like 3.2 gigahertz, where a desktop PC will these days clock up to like almost 5. And it's purely because it's stability. What did I do? Okay, I don't know. So this is my opinionated idea on like what you should sort of do for a home lab. You should basically make a plan. It doesn't need to be a complicated plan, but plan as much as you like to plan. Figure out what you're going to do. The how you're going to do it, you just need a USB stick, something that can write to the USB stick, and your destination for the USB stick, basically. And then obviously elbow grease. I always throw that in because you do need to recognize this is a little bit of a time and effort commitment over some of the other alternatives. Once it's set up, it's great. But I'm experienced at doing this now. It took me about 45 minutes to set everything you're about to see up, but I've done it half a dozen times over the years. So I'm not like, oh, I don't even know where to start. I don't have that phase of like doing the research on it. And hopefully this will eliminate some of that for you. Okay, so you're all on board. You're going to do this when you go home tonight. So I mentioned starting with a plan. If you have a goal in mind, other than just like, I want to set it up. I want to set it up, by the way, perfectly valid reason to do this. If you need to sell it to anybody you cohabitate with, I need this for work, or I want to do this to learn things, becomes a little bit more understandable to most people, I think. One of these options, I think you'll probably have a good guess, but I've never heard anyone say, but I'll leave it to the reader to identify that one. The one I'm gonna actually show is I would like to see how the Notepad++ compromise actually worked. So I want to be able to record a demo video or do a demo of that, possibly live demo. I might save the live demo for like in the room after the fact. You can kind of compile a list of everything that needs in terms of memory and CPU. You can usually make it work even on like things being tight. Like if you have a 2-core 4 gig of RAM system, you can usually make most software work on that, even enterprise stuff. It gets dicey the more enterprise you get. And I used to work at IBM, so I know this. I used to work at customer support for an IBM company, so I really know this. But yeah, you can, sort of a good rule of thumb is like, imagine 2 cores and 4 gig of memory for each major package you want to run. The more the better, right? To a point, don't go out and buy a used Threadripper system that has 192 processor cores and then be like, well, I'm going to run a Minecraft server and that's it. Like, don't do that. That's just a waste for you. Your power bill will go up too much to be valuable for that. The next thing you kind of got to decide is based on those packages, what am I going to do? Am I going to make a virtual machine or am I going to use containers? That'll kind of dictate which route you're going to go with what you install on the actual host system. If you're going to do anything with containers, you can start with any kind of Linux server OS and save yourself any time or headache. I would argue even in that situation, it might be good to have a virtualization host, if only to do snapshots and things like that, because snapshots are super great and valuable. But you probably already have familiarity with a bunch of the containerization stuff, right? Like, how many people in the room have not used Docker? Yeah, exactly. Okay, one person raised their hand, so you've been spared. Consider yourself lucky. So if you're not familiar with it though, like that's a good way to learn, right? Like okay, I want to set it up as containers. How do I go about that? Set up a Linux system, start working on it. Virtualization shines when you have a complicated network setup of systems, which is the scenario we're going to do today. So I wanted to build a test lab. These are the things I have as requirements. What I've chosen is Proxmox to act as the virtualization host. It is your stand-in for VMware ESXi, that kind of thing. It has a very nice web interface. I could talk glowingly at length about it. There are alternatives. Incus is very good. I have an Incus machine set up at home just to be able to learn it. It came out of an Ubuntu-based project to basically be sort of like the next generation of what the Linux containers project did. But Incus is fantastic, also has a beautiful web interface and allows you to have very fine-grained control over the things that you care about, but you can also just set up a container or a VM like that. It's really great for that, and it's designed for doing dev work. So you get a little bit of that flavoring into. You can do programmatic sort of builds and stuff. Cockpit is a Fedora project that does or I think it's Red Hat technically, but similar idea, web interface, be able to manage VMs, all that. And then you have sort of the other ones like VMware, VirtualBox, things like that. You can also just use built-in Linux. If you want to learn how the built-in Linux virtualization works, all these things sort of like piggyback off of that. You can just do that. There's no reason you can't. The next thing we're going to use is OPNsense. OPNsense is a FreeBSD-based router package. It is sold like on routers, but you can also get an ISO that you can just throw in a virtual machine and have it act as a router for your network. The only reason I'm doing that is because it has a nicer user interface than trying to do this all using firewall rules and NF tables and whatnot. It's just nicer. It's optional. You don't need to do that. And then lastly, I'm going to use the Pi-hole for DNS. Show of hands, who's familiar with Pi-hole? Okay, so for the folks who didn't raise their hands, Pi-hole is originally conceived as a Raspberry Pi project, or a project for Raspberry Pis. To be able to plug a Raspberry Pi into your network, have it act as your local DNS server, and block ads. That was the main goal of it, was like ad blocker on your whole network. But it's a DNS server, so you can do some things where you can customize how records are, and that's going to come into play later. All right. I'm interfering with it. So I think for most people, my impression is that the network services, like that fundamental underlying layer, is the scariest part. So having two packages that are like pretty much straightforward web interface, you don't have to, there's no archaic, I mentioned using bind at the bottom here. There's no archaic, like, go and edit a config file and add a key file, but the key file uses this really old PKI storage format that no one else uses anymore. Like, you don't have to worry about those things. You don't have to deal with that. You can just run the package and it does what you need. I marked it as optional for what we're going to do because you don't really need to do it. It's just nice to have. It adds some features and it adds some monitoring and logging, which is really nice. So this is the setup we're going to go with. Sort of step 0 is the question of whether or not we're going to give it internet access. I did, because I'm trying to interfere and man in the middle of an update process. And then the next question is, do you want to make a diagram, and how much effort do you want to put in? So this diagram is from DIA. It's like open source software, and it's got these lovely Windows 3.1.1 era icons. And so I think I might use it in every presentation going forward. It's pretty great. This is the information I gave you before about this laptop. It has, I've been saying, like, use small amounts of compute and all this, and then this is my old daily driver, so it has a lot of upgrades over the years. You don't need those. Certainly, I didn't even come close to assigning enough memory to be even a third or a quarter of this. I think I used like 8 gig of memory total. It does have 6 cores, which is like a little bit higher than some other old laptop systems. But again, you don't need those upgrades. Most virtualization will share the CPU. So even if you have like 4 cores, unless you mark them as dedicated, it's not going to just be like, well, darn, you're trying to run 32 cores worth of stuff on a 4-core system. If it's actually 32 cores worth of work, sure. But if it's 32 cores worth of VM, most of them are idle at almost all times. So it's not a big deal. This is just, I'm not going to go deep into this because these slides are sort of more for, I wanted to be able to give a reference for folks later on what the process should be. The gist of it is, and it's going to be repeated 3 times, download the ISO file, put it where it needs to go, install, repeat, dance. Once you get to the point of creating a network, we're going to need to create something special, which is like, we're going to have a network bridge that is going to be our fake internal network switch, okay? This is just, if you've ever created a bridge adapter on Linux for anything, this is all this is internally. It's just one that doesn't go anywhere. So it's literally only the devices on that bridge, and that's it. So we're gonna do that. It's very straightforward to add this in Proxmox. This is probably your first view of what the Proxmox GUI looks like, and I'm not showing it off at all well. They're not gonna say thank you for this. Then we're gonna do sort of the OPNsense virtual machine. We're gonna run through all the setup of this. Nice thing, you're setting up a piece of router software. Routers, a lot of them come with Wi-Fi adapters, so that's pretty easy to add, right? So we'll talk to that in a second. There's a bit of an asterisk. This is what it looks like to create the virtual machine for the firewall. The wizard is very similar. If you've ever used VMware ESXi, it's very similar to that process. You're just going through and basically answering questions at each step. The main thing to pay attention to here, I don't know why they did this. The Proxmox has changed how they set the type field here. The type field on the CPU thing is, and I'm calling this out only because I would like there to be a record that I call this. But the type field is essentially like what kind of processor to emulate for the machine that's going to run in the VM. And so the problem that creates if you don't pick host is that maybe there's a function that's being expected inside the VM that doesn't exist on your host processor, or vice versa. Always set it to host. I have no idea why they changed the default. The default is like it just picks some random value that it thinks makes sense, and it should just always be host. That's my very strong opinion about it. There's probably security concerns and stuff if you were to run this in production, which I'm sure some people are doing, but like, you know, we don't care. This is our test lab. We can break things here. And then basically all you're gonna do is when you get to the network step, you wanna pick that bridge that we created, that test LAN bridge we created, because we wanna say, look, you have a network adapter and it's on this thing. Then we're gonna go and we're gonna do a fun thing called PCI pass-through. Depending on how old your computer is, you might have trouble doing this. There's a feature called IOMMU. You can actually see there's a device ID for it there. IOMMU basically allows the processor to pass a whole device through to the VM and pretend like it's not part of its own system anymore. So most new systems have it, like anything since about 2017 or so will have it. It's just if you're trying to find something on the cheap, right? You're getting into an era of CPUs that don't necessarily have this feature. The nice thing about it is we can pass the whole device through to the VM, and then it just looks, as far as the virtual machine is concerned, this is just, oh, it's just part of my existence. So here we're going to pass it through. We're going to pick the Wi-Fi adapter here. And then that way, the router software will just see that we have a Wi-Fi adapter. And this is where I ran into the first problem. FreeBSD, which is what OPNsense is based on, does not have very good support for wireless adapters that are modern. The ABG era of Wi-Fi, perfect. Everything's great. Since then, so I found out, I did some troubleshooting, and this is where I like sort of spent the bulk of my time, was like, why isn't this working? So it turns out it's not as good. So what I did to work around this was I created a separate Linux VM on that bridge and just made it a Wi-Fi access point on Linux, and away you go. There is an appendix with instructions on how to do that at the very end of the presentation, because I didn't want to insert that after building this all out and then going through it. So, but the how-to is there. All the functionality is basic Linux packages that are available on any Debian system, so you can go ahead and do that. Then it's just installing. This is what the OPNsense installer looks like. It actually has like a usable functional terminal interface, which is nice. It's not just a shell where you have to remember commands, because it's meant to be in a, an actual router chassis and everything. You can go through, there's lots of guides online about how to set both Pi-hole and OPNsense up, so I'm not going to dig deep into them. Pi-hole, again, originally built for the Raspberry Pi. You can run it on anything. Anything Linux-based, it's just a package. They do a thing that I hate, where the literal only way to install their software is to curl the command and pipe it to the shell, or clone the whole repository and arbitrarily run the script. That is a terrible way to do things. Software packages, you should know better. Pi-hole, get your stuff together. You can, once it's running though, it's basically good to go and you have a cool web interface. This is OPNsense's web interface. What we're gonna do is we then need to tell the router, when you're giving out DHCP to people, use our Pi-hole as the DNS server. Okay, and sorry, I'm gonna, oh, there's a bit of like, okay. In here, when you're doing the setup, I didn't go into it, but in the guides, I prefer to use .2 and .3 on the LAN as your DNS servers. There's lots of guides on how to like set up an IP address on the system to be static and everything. Like it's just Linux setup at that point. Okay, so now we're set up, and now comes the fun part. We actually get to test this. So I set up another virtual machine, again on that bridge network. That is Windows 10. We're just using a trial ISO file. Like we're not going to use an actual product key or anything like that. And we're just going to install Notepad++ and see if we can actually like intercept the update traffic. So if you're not doing this specific thing, once you're at this point where you've got the router, you've got the Pi-hole, you got everything else, you can basically go. In fact, those parts are even optional. Once you've got the virtual machine host, you can just create any VM you want, set it up and play. And I strongly encourage you to like go and mess around and, spending 10 minutes the way an end user does. This is a frustration I've had since my customer support days, was that not enough of the development side of things was like the developers were spending the time to do the setup and work that an actual user has to. And so they were just looking at it as like, well, they have an admin who will figure this stuff out. And it's like, no, man, like you got to pave some of the like cow paths here, like make it easier for people to accomplish goals and they'll love your software. But yeah, definitely go play, get hands-on with stuff, mess around. You want to learn about SQL Server, set up a Windows box, install SQL Server on it, So Notepad++, I'll sort of run down the cliff notes of how that vulnerability happened. So there's two facets to this issue. One is what is believed to be a nation state threat actor compromised the servers that hosted their web infrastructure. So this is in the middle, in the sense that they got in the middle on the back side of things from the client perspective, right? The client is talking to the real web server and expects to get real legitimate updates from it. The other half of it was a security vulnerability that, to my understanding, was reported some amount of time, a substantial enough amount of time that it should have been addressed already, previous to when it was exploited, where Notepad++ was not checking updates for even so much as like a file hash integrity. So it would just update whatever exe, it would download the exe from the real website, but then it would just update whatever it was fed or what it was told to. Now, the nation state, Rapid7 has a write-up on this compromise. So if you're interested in the actual full details of what the malware looked like, you can do that through them. I encourage you to go check their blog post about it. It's kind of informative. The Notepad++ developers have been pretty transparent, and they like posted a blog like in their news section detailing sort of everything, including the recommendations they got. The vulnerability side was that they didn't have any code signing checks at all, so we're going to take advantage of that. Now, a thing to note that I put on the bottom here is that like a lot of Linux distributions pull their updates over HTTP. It's sort of business as usual. So the illustration I want to make with that is that this is a solved problem. This is something that we had figured out years ago. So if we're going to do the in the middle attack, we can't do what the threat actors did, right? We can't compromise Notepad++'s servers. I'm not claiming to have done that. But what we're going to do is we're going to fake it by essentially creating our own certificate authority and telling Windows, this is a trusted certificate authority, which I would guess maybe 60 to 70% of corporate networks already have that in place with their own thing. And how well do they secure their CA, right? My experience is not very well. So what we're going to do is we're going to go to the pie hole. Step one here is lie about where notepad++.org is. So then this 103 box, so this IP address I'm giving it is 10.200.200.103, okay? Where that 103 box is my actual attack system. That's the system that's going to be essentially intercepting the traffic and returning our evil payload, okay? On that system, you have to tell it where the real Notepad++ server is if you want to do a proper reverse proxy. The reason for that is because we don't want it to be obvious. We want you hit the website looks normal and fine. It's only the download link that's going to feed you bad data. So that's what we're going to set up here. Now, we're going to use a tool called Midem Proxy. Midem Proxy is you can sort of use it for any kind of traffic, but it's largely oriented around HTTP originally. It's meant for this kind of testing and this kind of traffic. It's also meant for monitoring and logging. Like you can do a lot of cool stuff with it. It's a little bit flexible on how you do it. So what we're going to do is just launch it with our CA signed web server key and everything that'll feed out as though it's valid for notepad++.org. And then what we're going to do is there's a -s npp replace.py argument on the command line there. That's telling it do everything in the script, like process all events in the script. And then we're going to use a really simple Python script. All this Python script is doing is essentially saying, hey, if this request starts with this get download url.php, this is a real where Notepad++ actually pulls its updates, then we're just going to respond with our own XML instead of the servers. The server on the other side never even sees this request, right? The client thinks that everything's legit because they're talking to a trusted source. And that's it. It's not a lot there. Just for comparison, I wanted to show you what the real XML update file looks like as of the past week. So on the left-hand side there, you'll see they've added code signing, which is great. But also that's what the sort of full XML setup looks like for sort of current versions. This is what we're feeding back to it, okay? This is the web interface for Minim Proxy. So it also has a web interface that's kind of nice. It's a little clunky to use. It's not designed for this, but I just wanted something that had prettier screenshots than a terminal. So now what we're gonna do is we're gonna watch the magic happen. So this is hopefully this will work. Okay, looks good. Let's see where my cursor is. Okay, let's just make sure that is. So, perfect, it's playing. So this is our victim Windows system. I'm gonna open up Notepad++ and tell it to update. It's gonna go out and check and say, oh, cool, we found this cool new update for you. Do you wanna update? Yeah, sure, okay, oh, we gotta close to do the update, great. Close it. Wait a second, that's not the Notepad++ setup. I felt like Calc was cheap, so I decided that Doom would be better. So we're going to install ZDoom. And I'm imagining this is the actions of the confused user, like what, how, why is this? So that's essentially what all we're doing is we're feeding it back our own sort of compromised executable. Does anybody want to see that a second time? It's not really glorious because it's like all the magic is happening in the back end, right? Here, let me come back over here. Oh, now the tricky part is I did not consider that I will have to restart that. Oh, there's only one slide anyway. Okay. Okay. So we built a whole test lab on this. I'll power this on so that people can know that I'm not a liar. It's not going to say much. It'll just say Proxmox virtual environment. Please log into the web portal. But if you have a laptop and you're interested, there's a Wi-Fi network that doesn't look like it belongs here. You can log in with the network name and take a look at everything. So, oh, what did I do? So I did want to mention that the Notepad++ team dealt with this compromise. I wanted to say, like, sort of kudos to them. You know, they were very transparent and open. A lot of other open source projects have not handled it as well as they have handled this. My only gripe is that it took them so long to do something that's been so obvious in the industry for so many years. And then also that it was a little weird, the reporting didn't happen the day they found the issue. They should have maybe alerted people to the fact that this was done. I know they were kind of early on from reading their words on it. They were kind of convinced that it was only being used against targeted users. So that's the thing. This threat actor wasn't sending bad updates to everyone. They were only sending it to their specific targets of interest, which was also kind of an interesting twist of that. And the web hosting provider was kind of able to confirm that through logs, like what traffic was directed. And they were seeing like a lot of traffic was still getting real updates. Probably that's like a tradecraft thing there where the threat actor was like, maybe we don't want to be loud with this and we want to get specific groups or people or, you know, what have you. But I still think this could have been reported pretty quickly, and maybe should have been. I don't know, maybe I missed it, but this kind of blew up in like beginning of the month, right? and it's kind of interesting from that standpoint. But at any rate, that is all I have for setting up a test lab. As promised, there is a whole section at the end with an appendix. I'm just doing this long enough so that people on YouTube will have a chance to pause it and see what they want. That is essentially how to set up your own access point. The access point should be running now, so if anybody wants to try and join the Wi-Fi and take a look, there's a fun Easter egg in there for anybody in the room. Yeah. Questions? Oh, thank you. Does anybody have any questions? Yeah, it looks like you have a question. No? Okay. Yes. Yes. You can do both, right? Phone virtualization is a bit of a pain. You're basically at that point, what you would do is set up an Linux system inside this network to do the VM or to run the like emulator for the phone. I prefer to do it on a real device because then you can actually, because virtualization or virtualized devices, first of all, they're slow. You're emulating like a completely different architecture most of the time. And it's difficult to work with. And a lot of like timing things are problematic. Like I've had it where like my emulator couldn't keep up with TOTP code rotation. So like what are we doing here? You know? So I found that like having a real device is valuable. That's why I got like a very cheap Pixel 7 that was damaged, because to me it's worth having, like I can live with that in order to do that kind of testing. So yeah, but you could do both. You probably want a more powerful system if you're doing that kind of emulation. Yeah. Any other questions? No. How do I hide the mess from my wife? Yeah, so I recommend, it depends on your living circumstances, okay? I recommend there's always a part in the bathroom sink behind things where like no one looks, right? For years. So you could just like get one of those like first aid kit boxes, just put it in that. Make sure there's some holes for airflow. No, in all seriousness, I have a server rack at home. I'm the wrong guy to ask. So I have a rack at home that has one thing I think I should stress. A lot of people seem to have the idea that like to run services, you need server hardware. You can do this on like old MacBooks or whatever you have laying around. Like as long as it can run the software the developers used to make the software, chances are you can run it. The thing you're missing out on is things like core counts and massive amounts of memory and stuff. So all but one of my home lab systems, and I have 8 of them probably at this point, which is too many. Like I'm not recommending anybody have that many. But all of them are old desktop computers that I had, with the exception of the other test laptop and now this. The one exception is I last year was like, yeah, honey, 4 servers is too many. I will consolidate. And I bought myself an Epic, a used Epic server system with 32 cores and half a terabyte of RAM, just to be able to pare down the amount of space it's taken up. But I do have a rack. Like, it's just like, once you have one, it's lonely if it's there by itself. You got to get more just so it has friends. Yeah, that's it, right? This is the only way. Yeah. No, I think, well, one thing I would like to highlight, I brought this lab with me here on public transit. Like I came here today taking the bus and the LRT. So you can do this very portably. And there are some people I know who travel quite a bit, who bring like a small router with like Pi-hole built into it and everything. Like you can do that with this too. And it doesn't look weird to have 2 laptops when you're going through security. Like it's pretty normal for some business people. So yeah. And then you can also do things like, I'll tell everybody, if you connect to this, the Wi-Fi access point is testlab.internal. The password is the access point name or the SSID. But if you connect to it and then access media.internal, there's a Jellyfin server running on it that has all of OWASP Ottawa's YouTube videos. That was just sort of as a show off kind of thing. I wanted to show Garth, and then I realized he's not going to be here. But yeah, but it's a demonstration of what the technology looks like. And if you want to look, if anybody wants to log in and take a look at it, I encourage you to do that. I'll leave it up and running for a little bit, just so that you can see what the web interfaces actually look like, play with. If you want passwords, I'll give them to you, because I'll just reformat it and move on with things. So doesn't need to be pulled apart. I know that Framework laptop computer company has geared their stuff around, like, you could turn this into a server when you're done with it, or you could turn it into a desktop when you're done with it. We sell a case for it. so that you can just pull the motherboard out of the laptop thing, slap it in this, and then it just looks like a desktop computer from 1980 where someone has scaled it down. But I don't bother with that. Just make it so it doesn't shut down when the lid closes and you're good. I think that's it though.
There was a ton of background on home labbing and the steps.
Yes.
This presentation.
Yes.
Where else? Like, are there where would you go apart from?
Oh, yeah. There's a bunch of communities. There's some Discord communities, although who knows how long those will be around with their changes that are coming. But Reddit has our home lab. If you get really into home labbing in the wrong kind of way, there's our data hoarders. Those who know. Data hoarders is for people. I think I have a lot of disk space at home. I have 60 terabytes across 2 different disk arrays. It sounds like a lot until then you read a thread where a guy comes along and he's like, "Oh, that's a lovely canoe you have. I'm driving my Ever Given." There are people who have like petabytes of storage at home. In fact, and some of them are preservationists, so they're like, game preservation is like a big thing. With certain political changes, there's been a lot of focus on preserving government records and open access to those kinds of records and data. So there's all kinds of things around in that space. Home labbing is more about like the idea of like, just, you can do this, like set it up, do it, play with it yourself. You can try it and be like, this is awful. And then you can return the laptop to the bottom of the closet and no one will ever know, right? But I encourage you to try it at least. Yeah. Yes, there is. Yeah, that's a great example of like, sort of like guerrilla thinking almost, of like, we need a way to communicate, but it's got to be a way that doesn't look suspicious. Well, kids like Minecraft. I have kids. I'll make a whistleblower server that people can come and tell me stuff. And it's like, okay, well, but there is stuff like that. Now, I'll say like I have like a ton of services that I host for myself at home. Some of them are legitimately useful, right? Like I have a Nextcloud service that Access sort of allows me to do automated backups from my cell phone. So I never have to worry about my cell phone getting lost or destroyed. Pictures I have on it are automatically backed up to my Nextcloud instance, and they're just there within a minute or so. It automatically takes care of that. So I'm getting the same experience of, say, iCloud or Google Drive or whatever without paying them a storage fee. And I don't have to worry about them sending me notices that they're going to be changing terms of service constantly or any of that. It's on my system. Now, I'm lucky. I have a friend who also is into home labbing, and we kind of have a cross backup setup. So we're each other's backups. So I back up all my important stuff to his place and vice versa. And then that way we have offsite storage. Our only problem is if a meteor hits us. And if a meteor hits my house, I'm not going to care. Oh no, I lost the photos. Like, like that won't be top priority. So yeah, you can find a friend to help with that too. Yeah, I'm trying to cult lead everybody into this. Just seems like. Yes, sir. Yeah. You can certainly like remove all the cloud stuff. It depends on what your goal is. So it depends on how complicated you want to get with stuff. Not everybody wants the setup I have where they have everything set up so that my phone automatically backs up to a server that then syncs to a friend's server at his house and vice versa. Like, not everybody needs to do that work or wants that work to set it up. What I used to do before my friend agreed to have this situation was I used to basically use Amazon Glacier storage. I would basically every night I would take all the photos on my system, put them in a tar ball because there's no compression, and then zip it, sorry, not zip it, then encrypt it, and then upload it to that. So it's encrypted with a key that I have on a password manager that, so yeah, you can kind of get away with not having those things available to you without, you can move away from Google Drive, you can move away from OneDrive or any of those things, and instead use this for storage. If you daily drive, if like your routine laptop is either a Mac or Linux, it's even easier because there's better support for some of those protocols. Windows, you can do it too. It's just Windows is very aggressive these days at telling you need to use their cloud services and nobody else's. Yeah. Sorry? Yeah. For storage? No. The thing is, like, I've seen people suggest that, but it's like, I'd be leery about it because things prune and purge a lot. You don't have control. Like, there's nobody's saying, oh, this person's going to pay us to take their data, so we better hold on to it and keep it safe and backed up. Those situations are like, well, it's kind of like I've seen people be like, well, we'll just back all my files up to blockchain comments. And it's like, well, it's like, sure, you can, but like, why? Yeah, yeah. It's like, why? And especially hard drives are like you can buy a 20 terabyte hard drive for, I think, like 130, well, who knows what it'll be next year, but right now it's like reasonably cheap. Let's say it's $250 even. 20 terabytes for $250 is incredible. Spinning disk hard drives still have very good density. So it's almost better to just, I know or knew a small business whose backup plan was back up to this hard drive, go to my bank, put it in their vault, take out my old hard drive, bring it back, and they would just basically rotate through their backups that way. And it was literally a hard drive sitting in a bank vault because it's a secure offsite location. It's got a lot of, now, whether that's good or not, I can't really comment on, but it fit their needs, right? So it's, yeah. Yes, yeah. I would basically never these days run any kind of large amount of storage without RAID. RAID is 100%. Yeah, yeah. It's basically a necessity. But yeah, it spins to, for those of you who aren't familiar with hard drive technology, we can get into that a little bit, but the idea is if you have, instead of writing the data and filling up one hard drive, then moving and filling up the other one, you can speed it up by writing it across the drives all at once. And then each drive is spinning and writing it at its maximum speed each time. So your throughput goes way up because you're essentially writing the bits across more things. That's a thing that solid, like spinning hard drives have to care about that NVMe and SSDs don't, because SSDs are effectively just writing the memory, which is why they're so much faster. But they're also going to be 6 times the price in 8 months. So yeah. 0%. Oh, actually, I have one set up at home. I have Olama set up at home. I have a weird GPU that I got at the right time, but I have a 4060 Ti 16 gigabyte, which that model is like a mid-tier model of card. It doesn't make sense that they made a 16 gig version, but they did, haha. The reason that's important is because you can load a lot of models into 16 gig that you can't load into 8. So yeah, I have it running just to experiment and play with, and I've tried all kinds of different models and stuff. So it's a good way to do that too if you're interested in testing that out. The problem that comes with is you need to get a graphics card that can run the models, and you probably need an NVIDIA graphics card practically for that purpose, and they're expensive and going to get more so. So yeah. Yeah. I think that's it, everybody.
Well, that was it.
We did. Barely.
Thank you so much, Fennix. Once again, we're here the third Wednesday. So expect it next month to be sure. Sorry, OWASP.org/Ottawa. Again, thanks to CyberSecurity for the pizza and University of Ottawa February for having us.